I'm Susumu Yamazaki. Call me Zaki. I'm associate professor at the University of Kitakyushu, Japan. One of my current research interests focus on system and social implementation using Elixir, Phoenix, NIFs, and NIFs. I am a co-founder and co-creator of pyramid series and satellite image processing systems with Elixir. First, I'll talk my motivation of this talk. When implementing a system that requires performance, we sometimes use NIFs, a mechanism for calling higher performance C code from Elixir. NIFs performs better than POT, another mechanism to call C. Fault-tolerant is an OS process whose program code may be written in C. It is safer than NIFs because it is protected under the control of OS. However, they have the disadvantage that NIFs crash. The entire Erlang VM will be abnormally terminated even under supervisor's control. A supervisor is a process which supervises other processes, which we refer to as a child process. Supervisors are used to build a hierarchical process structure called a supervision tree. Supervision trees provide fault tolerance and encapsulate how our applications start and shut down. This defect is a significant obstacles of NIFs when building fault tolerance systems. Here is a myth. A NIF always speed up your program. From the chapter 2, the 7 myths of Erlang performance of efficiency guide user's guide. Rewriting Erlang code to a NIF to make it faster should be seen as a last resort. It is only granted to be dangerous, but not granted to speed up the program. How should we do? This talk shows 3 points to describe robust NIFs. The first tip: appropriately set a conditional branch where each function call may return an uncertain value. Appropriately set a conditional branch where each function call may return an uncertain value. Okay? Example code. The function foo here assumes to return a pointer when it usually finishes, but to return null when it fails. We consider a situation to call the function bar with the return value of foo. The figure on the right shows code example that causes a problem. Foo bar. Why? The figure on the right shows a code example that causes a problem. Because this code will abort due to a segmentation fault when foo returns null. The function foo assumes to return a pointer when it usually finishes, but it to return null when it fails. So if there is this code in NIFs, even if a supervisor monitors the Elixir process that calls the NIFs, this fault will make the for VM that executes the process abort. Okay? Then, in this case, we should describe as the code in the right figure on right. The first step appropriately set a conditional branch where each function call may return an asserted value. Here, this is branch. Because foo may return an uncertain value, including null, we should set the return value to foo to temporal variables w. Judge whether w is null or not with a conditional branch. If w is null, this indicates the fact foo aborted. Then we should rescue this. In this example, throw an exception to Elixir by enif make bad arg. Otherwise, call bar with w to set. Enif make bad arg is a NIF function to throw argument error exception to Elixir to be returned from a NIF. Again, appropriately set a conditional branch where each function call may return an uncertain value. Okay? Next, the second tip. Perform error handling according to general conventions. Okay? Perform error handling according to general conventions. General convention of error handling in Elixir is here from error handling in Elixir School. For errors that are part of regular operation of function, a function returns tuple of OK and result and tuple of error reason accordingly. Okay, but for errors that are not part of normal operations, you throw an exception. NIFs should also follow this. An example code for errors that the part of the regular operation of function. The function should OK result. Here is the code of returning OK result. Here is make atom OK and result and make tuples. Okay. For errors that are part of the regular operations of a function, the function should return error reason as the figure on the right in case that error occurred. Here, okay. Fill the reason the error in the string. Describe the reason of error here. Elixir will receive error and reason, but not that child list describe the reason of error here. Instead of an ordinary string will be stored in reason. Of course, you can get an ordinary string instead of child list as a reason, but the code will be more complex, so I recommend to write as the code to get child list. Okay. For errors that not part of normal operations, the function should throw an exception. You can use argument error exception by enif make bad arg as the figure on the right. In Elixir, argument error. Okay. Next, for errors that not part of normal operation, but you want to other exception type with reason. So you can also throw Erlang error with reason by NIF raise exception as a figure of the right. Fill the reason of the error in the string, describe reason here. In Elixir, Erlang error, describe reason here. Note that char list instead of an ordinary string will be stored in reason. Elixir receive error reason, but not that char list instead of an ordinary string. Also, note that the child list instead of an ordinary string will be stored in reason. Okay. If needed, convert child list in reason to an ordinary string as the code in the right, the figure on the right. Okay. Here is the Elixir code. Raised to string is useful for this application. Okay, again, perform error handling according to general conventions. Okay. Next, the third tip. Make assertions that specify implicit preconditions and raise exceptions for supervisor to handle. Okay. Make assertions that specify implicit preconditions and raise exceptions for supervisor to handle. Okay, using assertion is able to make the program aborted when getting unintentional input or output to prevent bringing disruptive fault. The function square is in the right figure on the right computes the square root of the input of A. Okay, because the square root of a negative value is an imaginary number, the function squared gives an error. So when giving an unintentional input of A, that is a negative value, we should use assertion to make the program aborted. In this case, assert A is greater or equal to 0 ensures that the variable A after the assertion is 0 or a positive value. Though this assert is the function used in an ordinary C program, let's see how to assert a precondition in NIFs in the following slide. Okay. In NIF, instead of using assert.h, write a conditional branch that negates the assert condition and raise an exception as introduced in the second tip when the assert condition is violated. The figure on the right shows a part of calculation of the square root in NIFs. Here is assertion. Negate the assert condition. And exception. Here is a message. Assertion failed. A is greater or equals to 0. Function my skirt. And if raise exception with reason. Okay. In this case, an ordinary C program, assertion makes the program abort only. In the case of Elixir and NIFs, the combination of assertion and supervisor makes the program abort when an intentional input or output, relaunch it and receive another input. Supervisor in Elixir brings more practical use case of assertion. This is a powerful feature, okay? Again, make assertions that specify implicit preconditions and raise exceptions for supervisor to handle, okay? Okay, we understand how to describe robust NIFs. But how should we apply this method to existing libraries? If we cannot modify them or need to modify them to match, we should consider choosing ports instead of NIFs, okay? If we cannot modify them or need to modify them to match, we should consider choosing ports instead of NIFs. Summary. NIFs has the disadvantage that if they crash, the entire Erlang VM will be abnormally terminated, even under supervisor's control. This talk shows 3 points to describe robust NIFs. Appropriately set a conditional branch where each function call may return an assertive value. Second, perform error handling according to general conventions. The third, make assertions that specify implicit preconditions and raise exceptions for supervisor to handle. However, if you use existing libraries to apply this method and cannot modify them or need to modify them to match, you should consider choosing ports instead of NIFs, okay? One more thing. Today I learned I will be able to invite you to University of Kitakyushu in Japan as a student or students. Okay? This is big news. Japan, Kyushu, and I am here, okay? I'd like to share these details by the organizer of Elixir Conf Africa, okay? Coming soon. Thank you.
Was this worth your time? Hope so. Please subscribe to stay in the loop for more of this content. In case of any queries or suggestions, feel free to hit us up on Twitter. We'd like to extend a warm welcome to Elixir Conf Africa 2024. And here's the best part about this one. It'll be an in-person event. What a good excuse to come to Kenya. Again, we're super grateful for helping make this a success and definitely looking forward to seeing you in the next one. Cheers!